Moving on. So we looked at the EU-TRAN uh, piece of the architecture in the previous slide. Now we're going to talk about the EPC, and we're going to take into account each of these network boxes or elements, as you may want to call them, and examine what each of these does. For now, just become familiar with the terms, just keep these in mind. Obviously, these will make more sense as we go through the course. So the first network element that we briefly talked about in the previous slide was the mobility management entity. This is the box right here, and this is something that talks to the E node B here. As you can see, this connection is broken, or dotted or slashed, however you want to say it. It's not solid. That means that this is a signaling connection, as you may recall from the previous slides. So here, one of the key elements or functions is it is responsible for NAS signaling and its security. NAS just stands for non-access stratum, and what is NAS will become clear in the following slides. But for now, just keep in mind NAS means non-access stratum. MME is also responsible for tracking area list management. What tracking areas are, you can think of tracking area. So, okay, let's first understand what tracking area is. So you can have multiple EU-TRANs, right, within your network. A given EU-TRAN is identified by a tracking area code that is specific to that EU-TRAN. It is the responsibility of the MME to keep track of all the tracking area codes within a given network. So that's why we say it's responsible for the management of the tracking area list. The MME is also responsible for selection of the PDN gateway and the the S gateway, serving gateway, and the packet data gateway. So as you can see here, there are two network elements, serving gateway, and there is a packet gateway here, right? So the MME, based on certain criteria, selects which serving gateway and which packet gateway to select, given from a pool, because you can have multiple instances of these depending on the size of your network. A small operator can only have maybe one of these, or like a big operator, can have a few of these, a few of these. So the MME uses some logic to figure out which of these to select. So it's a responsibility of the MME to figure that part out. It is also responsible for roaming and authentication of subscribers. So in this case, subscriber meaning a user equipment or a smartphone or a device. The authentication is managed by the MME. And MME is also responsible for a bearer management, EPS bearer management. I won't describe what a bearer is here. I have one of the later slides here, but it is responsible for that. It is also responsible for signaling for mobility management between 3GPP RANs. So, obviously we have, while we are building out 4G, we'll have 3G and in some cases 2G networks also, and there will be an overlap between these networks. So the MME, what it does is, one of the functions is it controls the mobility as a UE may traverse between 3G and 4G. So a good example would be, say you're watching YouTube on your phone, and you move into a 4G coverage area, whereas previously you were on a 3G, right? So you don't want your connection to drop. So the MME in this case makes sure that your connection is retained, and it's true the other way. So you are in a 4G coverage right now, and say you go into a 3G coverage, and while watching YouTube, you don't want your connection to be dropped. So in this case, the MME makes sure that your connection is retained, and it takes care of all the signaling between the 2G, 3G, 4G networks. So moving on, the another network element is the home subscription server, or the HSS, which is located right here. This network element is responsible for user authentication, and also subscription/profile management. So user authentication, let's talk about user authentication. So like I said, LTE, there is a big emphasis on security, and the way that they do that is by allocating certain encryption keys as well as certain specific keys to every subscriber or user equipment in this case. And those keys are stored in the HSS. And that's the only place they are stored in the network. So this is sort of like a bank, right? It has all these keys. And if there is a network element like the MME that needs these keys, it's going to go grab these from the HSS. Um, so that's why it's the central place for user authentication. The other thing it does is it also manages profiles. So you may ask, what is a profile? So profile um, is sort of a list of services that a user equipment um, can access. For example, say you go and get a device, right? And you go from, say, India to Australia. Now, your network operator only wants you to roam while you were in India. Say you wanted to go from one state to the other state, but they don't want you to roam when you go to Australia. So that kind of control would be defined in the HSS, and it would be defined in what is called a profile, where they can enable roaming for foreign networks. So that's the idea behind profile management. One of the other things they can also do in profile, when I say they, I mean the network operator, they can impose throughput limits. Say they wanted you to get a max speed of say 10 megabits per second, and they don't want, so what that means is they don't want your user equipment here to get more than 10 megabits per second. So that kind of control can be exercised in the HSS. So you would define again it in your profile, and that profile is specific to the UE. And the way it works is when a UE attaches to the network, it gets registered in the MME, and the HSS sends that profile information to the MME. So the MME is aware of what your max throughputs are, what your roaming restrictions are, if there are any, and makes sure those are respected by the other network elements like the EU-TRAN. So that's the function of the HSS. Moving on, the serving gateway, or the SGW as it is referred to, this is the network element here. This is responsible for packet routing and forwarding. If you recall from our EU-TRAN discussion, when we were reviewing EU-TRAN, there is a user plane link between the eNode B and the SGW. So the SGW is responsible for making sure that the packets meant for a given UE are delivered to the UE and vice versa in the opposite direction. So this kind of acts as a packet router and a forwarder for packets, right? The other thing it is responsible for is EU-TRAN idle mode downlink, or DL, packet buffering. So what this means is, say a user equipment is not currently attached to a network, and there is a incoming WhatsApp message for that user. So what this SGW is going to do is the WhatsApp message makes its way from the internet to the packet gateway to the serving gateway. The serving gateway figures out by some logic that the UE is not yet connected. So that WhatsApp message is actually buffered here up until the time that the UE connects to the network, at which instance that WhatsApp message is delivered to the E node B. Why this connection here? So that's the function of the serving gateway. The other thing it also does is UTRAN and inter 3GPP mobility anchoring. Okay, so what this means is, say you move the UE moves from one E node B to the other E node B. While this UE is moving, while this UE is moving, which we call as handover, it's handing over from one E node B to the other E node B. The serving gateway buffers all that data that's coming in downstream for this particular UE. And at the instant where this UE successfully hands over to the other E node B, that data is delivered to that E node B. So that's what we mean by anchoring, specifically UTRAN anchoring. Again, like I said, there can be 3G network that is overlapping with 4G, and you are handing over between 3G and 4G. In that instance, the serving gateway also buffers your data. The other important function of a serving gateway is also what is referred to as charging, uplink and downlink charging, per UE, PDN, and QCI. So the serving gateway is actually the network element that keeps track of how much data is being transmitted towards a UE, as well as how much data is being received from the UE, right? So all your billing information happens in the SGW. Actually, what SGW does is it generates what are called CDRs, or call detail records. And these call detail records have the exact information regarding when the data was transmitted, how much data was transmitted, which UE, which service, everything. So these can be ingested by your billing system, and they can post process them and bill the users. So that's the intent behind the serving gateway. Okay, moving on. So the last network element in the EPC is called the packet gateway, or the PGW as it is abbreviated as. It's responsible for IP address allocation. So if you guys are familiar with the networking concepts, you will have this guy, since it's an all IP architecture, this endpoint user equipment needs to have an IP address, right? That IP address is actually assigned by the packet gateway, or the PGW. It also is responsible for packet filtering and policy enforcement. So what that means is this PGW keeps track of which data needs to be sent to the UE. And the way it does that is it filters packets because it keeps track of which UE is requesting which service, and based on that service, as packets come, say, from the internet, it knows what the destination of those packets needs to be, and it makes sure that those packets make their way to that UE. And the way they do that is they come from the PGW, go to the SGW, go to the E node B that the UE is currently connected to, and then the E node B transfers the data to the UE. Another key aspect is transport level QoS mapping and marking. Okay, so let's talk about QoS. So QoS stands for quality of service, and as you may be aware, there are different applications that run in LTE, right? So you can have video, you can have voice, you can have text message, and each of these services actually has certain requirements around latency and priority. So each of these requirements is actually referred to as a QoS mapping. And what this P gateway does is it knows which service is coming, or is being requested by a UE. So it makes sure that the QoS is respected for every service. So if it's video, if it's voice, it knows that the packets need to get to the UE really fast, right? So it does the appropriate logic to make sure that the packets, as they make their way from the P gateway to the SGW to the E node B to the UE, they get there in the right amount of time. And the way it does this is by mapping the QoS. So again, it is also responsible for anchoring of data packets, as this UE may move between 3G, 4G, or maybe between different technologies, right? So that's pretty much it for the EPC architecture. I hope it is a little more clearer than before. Just to recap, right? So we looked at the MME, we looked at the HSS, we looked at the serving gateway and the P gateway. So this diagram here is kind of like a summary of what we have reviewed so far. It's broken out like in the EUTRAN and EPC with all the different network elements. This is the same diagram as before. What we have added here at the bottom are the different functions that each of these network elements is capable of doing. So you can have E node B can do all these functions. You have the MME, which can do all these functions. The serving gateway has these functions. The HSS has these, and then the PDN gateway has these functions. So some of these we've already reviewed in the previous slides. Some of these we haven't yet touched upon, but you can do some more research on your own and get a sense of what each of these mean.